Welcome to the podcast. I'm William,
And I'm Kat,
and that makes this Info on the Go.
answering questions you want to know.
So I know the title is really kind of off-putting here, but you know, today we're really going to talk about time travel. It's been a dream, a nightmare, a Hollywood blockbuster, but is the science fiction, or is there a grain of truth in the physics? Did Doc really help Marty get back in time? Going back in time. I'm sorry. Uh, it just came up. I can see Marty and Doc standing there looking at the clock going, "Oh, it's gonna strike here."
Right.
It's gonna be back out in theater. Well, I think it hit theaters this weekend.
Oh,
Yeah, I'm gonna try to go see it. I don't know if I'll be able to, but I'm gonna try.
right. Smuggle some candy in and stuff because can't buy
Oh,
that popcorn either.
no, I shoot, you can drop $1,000 in there.
Yeah, I'm serious. It's
You know what
crazy.
the markup on popcorn is?
No,
What is it, like 1,000%, 2,000% or something other?
I have no idea, but I believe it. Oof. So, today we're going to explore what modern physics, relativity, quantum theory, and paradoxes tell us about possibility of traveling through time.
So today we're going to kind of talk a little bit about Einstein's theory of relativity and time dilation.
Wormholes and space-time concepts,
Quantum weirdness and paradoxes.
practical limitations, and cultural impact.
Would Marty McFly really have disappeared if his mom hadn't hooked up with his dad?
Ooh.
So, before we get started, we should really tell our listeners we're all time travelers. Every second that passes, we move forward in time, and exactly 1 second per second, we're time travelers.
We're constantly in the middle.
Yeah, have you ever thought about that?
I try not to think about it.
So we're kind of like the doctor. The doctor?
Yes.
Yeah, we're kind of like the doctor.
Well, and of course, then there's the split realities theory too that goes in with all this.
Or the string theory and multiverse and
You're
stuff. But
right, right.
we're going to talk about the Flash at the end. So let's move on.
Um, so we can't stop or reverse time, of course. Travel isn't just science fiction, though. It's a constant reality. So an example of time dilation, astronauts on the ISS or the International Space Station orbits Earth roughly at 17,500 miles an hour or 28,000 kilometers. Clocks on the ISS run slightly slower than clocks on Earth due to special relativity or speed and general relativity or weaker gravity at orbit.
So the result is astronauts age milliseconds less than people on Earth over months of long missions. It's a tiny but measurable form of time travel into the future. Fun fact, this is called the twin paradox in physics and thought experiments. And the reason why it's called that is if you have twins and you have one in space that's on the space station for a longer period of time, and you have one on Earth, the one that comes back from space will be, milliseconds younger than the one on Earth. We got some real life experimental proof here as we kind of move forward.
Atomic clocks on planes, and scientists flew extremely precise clocks around the world. When compared to stationary clocks, the flying clocks recorded slightly less time.
But, what are atomic clocks? They are super accurate clocks that use atoms to keep time. And atoms tick very regularly. So these clocks don't really lose or gain time like normal clocks.
And scientists use them to measure tiny differences in time, like the tiny slowing down of clocks on fast moving planes or satellites.
I think we should add to the shopping list clocks.
Yes.
Okay. So here's a simple analogy. Imagine a normal clock is like a regular heartbeat, sometimes a little fast, sometimes a little slow.
An atomic clock is like a perfectly steady metronome that almost never wavers.
So
Gee,
I wasn't sure if you wanted me to do it or not.
you
You
were
know,
going for it, I was going to let you.
well, I took a deep breath and I was like, okay,
I heard the deep breath. I
all right.
heard I heard the I want to say it.
No, you do it. You go for it.
Okay. So, GPS satellites, engineers must correct for both speed-based and gravity-based time dilation. So, without these adjustments, GPS navigation would drift by kilometers every day.
So what really happens here in these experiments, they confirm Einstein's predictions about time being relative, not just theory, but actually measurable reality, which is, huge. So moving faster equals time slowing down. So the concept from special relativity, the faster you move relative to someone else, the slower your clock ticks compared to theirs. So moving faster equals slow time.
Huh. Uh,
No,
I mean, I understand the concept. I do. I understand the concept. And there's a but there, but I'm not sure what the but is right now.
Einstein was a genius. So
The thought experiment here is imagine a spaceship traveling near the speed of light for a year, and when you return to Earth, decades might have passed for everyone else. Essentially, you've traveled into Earth's future.
So the counterintuitive nature, time is not absolute. It really depends on your motion and gravity. So I think we really kind of need to explore how gravity and velocity warp time even more dramatically, leading to real life time machines like black holes.
So, special relativity. The time depends on your speed. Einstein discovered that time isn't the same for everyone. It changes depending on how fast you're moving.
So if you're moving really fast, everybody else around you is really slow. So if you're the Flash, huh, you would always be in the future, right?
Right, right. Another analogy would be imagine two clocks. One stays on Earth, one rides a spaceship close to the speed of light, and the spaceship clock ticks more slowly.
If you took a spaceship traveling near the speed of light, which is impossible, when you return, your friends on Earth could have aged decades, but you would definitely be younger than them. You might be Marty McFly and you can't go back in time like he did.
Right. And the fun fact is, this is called time dilation. It's not science fiction. It's been measured in experiments with atomic clocks on fast moving planes and satellites.
But general relativity, gravity also it changes time too. So gravity doesn't just pull objects. It bends space and time around heavy objects. The gravitational time dilation, the stronger the gravity, the slower time moves for someone near that heavy object.
Hmm. So, near a black hole, a few minutes for someone close to the black hole could equal years for someone far away.
So, GPS satellites are slightly farther from Earth's gravity, so their clocks tick a little faster than ours. Engineers have to correct this, or your GPS would put you off by kilometers each and every day. And how fun would that be?
That would be excellent, I'm sure.
It would be. It would be like the early days of GPS.
I was gonna say, if anybody remembers the early days of GPS, it was hit or miss.
It was, yeah, 100 feet, you reach your target. Wait a minute, I'm in the middle of nowhere.
Right. The movie is Interstellar. Characters near a black hole experience time differently. Hours near the black hole equal years on Earth.
So, this is a real effect predicted by Einstein, showing how science inspires storytelling. At least they did their research.
That makes the idea of traveling into the future understandable and exciting for audiences.
Yeah, if you're sitting there and you're really putting Einstein's theory into your research and really making it seem like it's something that could happen, I think it makes for a better story, right?
Right.
But, everybody talks about wormholes, black holes, and space-time tricks. I say we kind of break all of those down.
So, what is a wormhole? And it's a theoretical tunnel through space and time, like a shortcut connecting two distant points in the universe.
So imagine space as a flat sheet of paper. So if you draw two dots far apart, traveling between them would take, a long time. But if you fold that paper so that the dots touch and poke a hole through it, you can jump instantly from one side to the other.
That hole is what scientists call a wormhole, a shortcut through space-time. In theory, you could travel through it to reach another place or even another time, but in reality, we've never found one. And it would likely collapse instantly unless held open by something exotic, like negative energy or exotic matter.
So imagine the universe as a giant map. Instead of taking the long route, a wormhole could really be a shortcut across space and time, and you could instantly get to one point to another. We need that for driving around on Earth.
Ugh,
I
that would
want
be so great. Do you know how much money I would save on gas?
Yeah, I mean, you just walk out, you create you a wormhole, you go straight to work. Do you know if we did that, we could just get rid of our cars? You could just walk through the wormhole.
Yeah, dude, emissions. The
Yeah.
oil industry would plummet.
We need a physicist to create wormholes on Earth. I don't know though. It might create some kind of rift that would just like suck us into a big black hole. So, you know what?
I don't know.
If it's theoretically possible, well, we could be like the Jetsons and create what do they have? Those little pads you would stand on and
Yes, yes,
kind of like Star Trek. Warp me
absolutely.
there, beam me up, Scotty.
Right.
Anyway, I'm sorry, way off track.
But the challenges and speculation, kind of what we talked about, is wormholes aren't naturally stable, so they'd collapse instantly without exotic matter, which is a hypothetical substance with negative energy.
If wormholes could exist, they might allow travel forward or backward in time, depending on how they're used.
But this is all purely theoretical. We haven't built one, and it may never be practical.
And I don't think Kat and I are ready to build a wormhole.
No,
Yeah,
no.
we'll leave that to the professionals. So, black holes and time dilation. A black hole is a place in space where gravity is so strong that nothing can escape it, not even light.
Yeah, so imagine squeezing a star much bigger than the sun into a tiny ball. The gravity becomes incredibly powerful, and anything that gets too close, a planet, a spaceship, even light gets pulled in and can't get out.
And then the boundary around it is called the event horizon. Once something crosses the event horizon, it's gone forever from our view. So we don't really know what happens to it.
But inside space and time are stretched to the extreme. So time itself slows near a black hole. So if you watch someone falling in, they'd seem to move in slow motion as time almost stops.
Scientists think black holes warp space-time, and some theories even suggest they could connect to wormholes. Though, that's really still speculation at this point because nobody really knows.
And as we've said before, extreme gravity near a black hole slows time dramatically compared to someone far away from it. So spending just a few minutes near a black hole could mean years pass for people further away.
But the danger of all of this is black holes are deadly. You'd be torn to shreds before even enjoying a little time trip there.
Mm,
Because, like you said, the black hole condenses, like if you take a great mass, think about like I don't know, something like a basketball, and you condense it down to something like the head of a pencil. That's what we're talking about in a black hole. Just saying.
it's wild.
It, yeah,
It,
those are
it
wild
just,
times. I took your words from you.
those are wild times. But not only that, it just keeps sucking stuff in.
Yeah, it does, and it just keeps compressing it down and compressing it down. It's crazy. Wormholes and black hole time travel are allowed in Einstein's equations, but creating or surviving them is really far beyond the technology that we have today.
It's great for science fiction inspiration, though, showing how physics allows imagination to explore time machines.
Well, if you're Marty McFly, you don't have to worry about any of that. You can just use the flux capacitor.
I was going to say, you just need your flux capacitor. Don't
So,
lose it.
yeah, don't lose it. And definitely make sure you got plenty of plutonium to keep that thing going.
Yeah, no matter what time period you're in.
Well, didn't he was it two or three that he was able to use garbage to make it go?
I think so.
Yeah, I can't remember. I remember the train in like three, or was that four? Anyway, Marty goes back to the Wild West.
I thought that
Quantum.
was the second one, and the third one was where he went to the future.
Oh,
Or
you know
was that
what?
backwards?
No, because the first one he went back in time. The second one he went to the future. And
Yes.
then the third one he was in the Wild West.
Okay, let's get that straight though. Let's.
Because he made the comment about duck hunt
Hmm.
when he
Hmm.
was sitting there with the guns and stuff. That was number three, where they rigged up the train to travel back into the future.
Right, and Doc, you had to go find Doc because he didn't want to leave.
It's kind of weird though how all of the characters were in every time period. Like Biff was around, Doc was around.
We all look like somebody from the past, right?
Let's get back to this. So, quantum weirdness, right? At the tiniest scales, particles don't behave like normal objects.
They can exist in multiple states at once until observed, and this is called superposition.
So, observation seems to choose one outcome, but other possibilities may still exist in one sense or another.
This is where my brain loses all of its understanding of life. It does. It loses it. Okay. Um, Many worlds interpretation of this. Some physicists suggest that all possible outcomes happen and each in a separate parallel universe.
Yeah, so traveling back in time might create a new timeline rather than changing the original timeline. And if anybody is a fan of The Flash, you know when he goes back in time or changes time, he creates a whole new timeline. So really, that's that theory.
Right. And this idea helps explain paradoxes like the grandfather paradox. If you went back and changed something, it would erase your original timeline and it would just create a new branch.
But you would still go back in time, so you would still be around. See, that's a paradox. It's a conundrum. Like how can you do that?
I think we should explain that the idea of superposition comes from a famous thought experiment called Schrodinger's cat, created by physicist Erwin Schrödinger in 1935.
So imagine a cat inside of a sealed box with a tiny bit of radioactive material, a detector, and a vial of poison.
If the atom decays, the detector releases the poison and the cat dies.
If it doesn't decay, well, the cat stays alive.
So, according to quantum physics, until someone opens the box and looks inside, the atom is both decayed and not decayed, meaning the cat is both alive and dead at the same time.
Yeah, so this weird idea really shows how particles in the quantum world can exist in multiple states at once, and that's superposition. But once we observe or measure, they really choose an outcome.
So, Schrodinger's cat wasn't about an actual cat. It was his way of showing how strange and confusing quantum rules can be when we apply them to everyday life.
Yeah, so a cat in a box is both alive and dead until someone looks inside.
And in many worlds of view, when the box is opened, the universe splits, one where the cat is alive and one where the cat is dead.
But time travel could split timelines, allowing multiple histories to coexist without contradiction. So, yeah, that literally can blow your mind. I get it.
Yes.
Okay.
Nothing is, if a tree falls in the forest, doesn't make a sound.
I mean, quantum mechanics, it really suggests that the past may not be a fixed timeline, or at least in theory, though, right?
Yes, maybe.
Maybe. So time travel might not violate physics if it follows the rules of, branching universes and avoiding paradoxes. So multiple timelines, string theory, that's where all that comes from, right?
Uh-huh. Yep.
I think before we get into paradoxes of time travel, I think we should take we should take a small break.
Sounds good to me.
Stay with us. We'll be right back.
Looking for your favorite band, team, or TV show, maybe that movie? Since 1969, Old Glory has been the ultimate destination for officially licensed merchandise, with over 300,000 items in music, sports, movies, TVs, and popular culture. And you have Christmas coming up. Have that hard to find person that you're looking for? Check out Old Glory. At checkout, use our exclusive listener discount code and get 15% off any product. All you have to do is put InfoGo in at checkout. That's InfoGo at oldglory.com. You can find the link in the show notes.
Are you too hot at night? Well, say hello to the world's softest sheets. Cozy Earth's bamboo sheet set keeps you cool, dry, and comfy all night long. It's made from bamboo. They're moisture wicking, breathable, and get even softer with every wash. Did you even know that you can make sheets out of bamboo? I didn't. I thought that was awesome. And they have pajama sets. Pure cozy elegance, stylish, silky, praised on Good Morning America and in style, and backed by thousands of five-star reviews. You can't beat the 100-night sleep trial and free shipping on over $50 plus a 10-year warranty for sheets. 41% off any product with code INFOGO at CozyEarth.com. Make sure you find the link in the show notes.
All right, Kat. So now that we back, now that we're back, you want to take on the grandfather paradox?
Absolutely. If Imagine you build a time machine and travel back to a time before your grandparents met. And out of curiosity or accident, you prevent them from meeting. And maybe you distract one or move them to different towns. That means your parents would never be born, and neither would you.
So wait a minute. Basically, what you're saying is if you're Marty McFly and you travel back in time and your parents don't meet, you would really vanish from the photo?
Essentially. And in
But
that reality.
yeah, I mean, I guess so. So the logical problem here is if you were never born, you could never have gone back in time to stop them from meeting, right?
Right.
So if you didn't go back, then they would meet and you would be born, which means you could go back. See what I'm saying? It kind of creates an endless loop with no consistent solution. Reality seems to contradict itself in this.
Right. The paradox shows the logical limits of changing the past. It's just that if backward time travel is possible, something must prevent paradoxes, either by blocking changes or creating alternate timelines.
But we do have some possible explanations from physics and philosophy. Novikov, self-consistency principle. The universe protects itself from contradictions. Events might rearrange to make sure the past stays consistent. For example, your attempt to stop your grandparents might always fail some way somehow. In other words, you can visit the past, but you can't change the past.
When you change something in the past, you create a new version of history or a parallel universe. And in that new branch, your grandparents don't meet, but in your original timeline, they still did. So this avoids contradictions because each version of events exists in its own separate timeline.
Let's go back to the Flash. Anyway, enough said, right? Do you like
Mhm.
the Flash?
I do like The Flash. I didn't finish it out, but I watched
Oh, you're
a lot
talking
of
about the series. I'm talking about I was a kid comic book from day one. I watched the original Flash series, the cartoons, and then the series. I loved the series that CW had, but no, the Flash is my guy.
it.
Well, I mean, Batman is the guy. Like he's the guy because he's human, right? So Batman has to win at everything. But Barry Allen is also human that.
So are you telling me you prefer DC over Marvel?
I'm telling you that I prefer real superheroes like Batman and the Flash.
Those do seem to be DC, correct?
So the grandfather paradox is a favorite theme in movies and books, from like Back to the Future to the butterfly effect. And I think we should do one on the butterfly effect.
Yes.
Noticed I avoided your slam at me, right?
I wasn't slamming at all. It's not going to be another Coke or Pepsi for us. I mean, I like both, so.
I like both too. I grew up reading comics from Batman and Superman and the Flash. Those were my three go-tos. I didn't really care for Captain America and didn't really care for Thor. Thor had a great story and everything. Now the movies, yeah, I like those. But as far as like the comic books, because Batman was originally dark.
Mhm, mhm.
And then that 70s TV show was really to make fun of Batman. But whatever, 60s, I think it was he came out. But Barry Allen has always been my guy, and so is Bruce Wayne.
Okay, okay, fair enough.
Yeah, well, they're human.
Right.
Well, I guess Captain America's human too, though, right?
True, I guess so. It's not just about time travel, though. It's about whether we can ever truly change what's already happened.
To really kind of break down the grandfather paradox here, it, it isn't just a puzzle. It's a window into how fragile our idea of time really is. It shows that if time traveled backward were ever real, the universe would have to choose between consistency or chaos.
And let's move into the bootstrap paradox. Uh, the basic idea is it happens when something exists without a clear origin. It loops endlessly through time. And it's named after the old phrase, pulling yourself up by your bootstraps, meaning do something impossible by your own effort. And in this case, an object or idea seems to create itself with no one ever truly inventing or starting it.
All right, let's see. So, a scientist in the year 2200 builds a time machine and travels back to 1900. So, she gives her plans for the time machine to a young inventor in that year. That inventor uses those plans to build the first time machine, the very one the scientist later uses to go back in time. So, who actually invented the time machine?
Huh.
You see what I'm
That's a,
saying?
that's a good question.
Because the design is going to exist, but it really has no true beginning because it keeps cycling through time.
Right.
I mean, you see, it's like all these different conundrums with time travel.
Oh, maybe this next example will help. A musician from the future travels back and plays a famous song for a struggling composer. The composer records it and it becomes a hit. Decades later, the time traveler learns the song and decides to take it back to inspire the same composer, creating an endless feedback loop. So the song exists forever, but no one truly ever wrote it.
Yeah, so this is the song that never ends. Some people started singing it not knowing what it was, and they'll continue singing it forever just because you've never heard that.
Wow. That
You-
does bring a whole new meaning to that song.
Anyway,
The bootstrap paradox highlights a different kind of time travel problem, though. Not contradiction, but causeless creation. And it challenges our idea of cause and effect. Every event we know has a beginning, but in a bootstrap loop, the beginning is missing.
I guess let's really take let's take on closed time-like curves. Einstein's equations allow loops in space-time where cause and effect circle back on themselves. So physicists like Kep Thorne and Stephen Hawking have explored whether such loops could exist.
In some quantum interpretations here, some physicists suggest that bootstrap loops might be possible if quantum mechanics allows information to preserve itself through time without breaking physics laws. And others argue it's impossible because it would violate causality and the basic rule that causes must come before effects.
So, have you ever seen Doctor Who?
Of
Uh,
course,
yeah,
Doctor Who, Tennant, Predestination, and Harry Potter and the Prisoner of Azkaban.
yeah. So writers love it because it bends the mind. Something appears from nowhere, yet feels perfectly consistent inside the story.
And it raises big questions about fate, free will, and creativity. If ideas can exist without origin, what does that say about time and human invention?
Man, you just broke my brain. I mean,
Time, timey-wimey, wibbly wobbly stuff.
yeah, I mean, I think after this episode, my brain is it's gonna need some healing. So the bootstrap paradox doesn't break logic, it loops it.
It's less about erasing the past like a grandfather paradox and more about recycling it forever.
But it reminds us that time, cause, and creation might not be as straightforward as they seem, and that sometimes the loop itself is the mystery. I mean, yeah, my brain is just broken now.
Casey likes to watch this stuff to go to sleep too.
I do too. That I got this idea from, and I'm gonna have to erase this. I was watching Curiosity Stream, and this guy, it was one of these physicists. He was talking about how it was logical, and I was like, "What? This would make a great episode." And this was born.
I see. So, philosophers and physicists takes on can time travel make sense? That's the big question here. If time travel were possible, how could the universe handle paradoxes without breaking reality?
So the Novikov self-consistency principle was proposed by Russian physicist Igor Novikov in 1980. And it suggests that the universe doesn't allow contradictions. You can travel to the past, but whatever you do, there must be consistent with the timeline that already exists.
And the example here is if you try to stop your grandfather from meeting your grandmother, something will always stop you. Maybe your plan fails or events unfold differently, but the outcome stays the same. You still end up being born.
In short, you can visit the past, but you can't change it once you get there. So you can't be Marty McFly and go back and separate your parents and let Biff get in the way. It, it's it's just not going to let it happen. So,
Yes.
even if you had the little sports comic book, you couldn't go back and like bet on a bunch of stuff because you would still be broken in the future.
Right. And, now we have time splitting and the interpretation of many worlds. Based on ideas from quantum physics, especially the many worlds theory by Hugh Everett. And here, when you travel to the past, you can make a change. You don't rewrite history, you branch off into a new timeline.
Yeah, so the old timeline, it still exists, but now there's a parallel reality where your actions created a new version of history. Imagine Barry Allen going back in time and creating two timelines,
Which he did
multiple times,
many, many times. And
many.
that eventually caused a problem too.
Yeah, from the comic books that I read all the way to the original show and to the series. Yeah, he was always jacking up time there and creating multiple timelines.
Causing a problem.
As he would do.
Mm-hmm.
Yeah.
Fixing stuff but causing problems too. In any case, the example here is if you stop your grandfather from meeting your grandmother in that new branch, you're never born, but in your original universe, nothing changes.
In short, you can change the past, but not the past. I mean, I don't know how else to put it. So, why do these ideas matter? Both theories are still theoretical, right? But they really kind of help scientists and philosophers think about how time travel could logically work.
Right. And the Novikov principle keeps time travel tidy and self contained. No paradoxes allowed.
And the many worlds view, it embraces branches of realities, messy but still possible, kind of like Barry Allen, messy
Right.
but still possible.
And together they show how our understanding of time blends physics, logic, and imagination.
So, time travel paradoxes inspire stories, movies, books, from Back to the Future to Looper and Avengers Endgame. See, I'm outside of DC there.
Fair enough. But these paradoxes capture our imagination, letting us explore the consequences of messing with time.
I guess let's kind of take a quick tour of famous time travel stories, right? You want to do that?
Yes. Yes.
So I'm going to start with my favorite, Back to the Future. Michael J. Fox, teenager, he travels back to the past and accidentally changes his family's history. This one really kind of explores the grandfather paradox in a fun but humorous way, and Michael J. Fox really set the tone for that. He's a great actor, by the way.
Yes, yes, he is. I also loved him in Atlantis.
I never saw that one. I saw Teen Wolf. I watched him when he was Alex on Family Ties.
Yeah, Atlantis might be too young for you.
Okay.
So next up we have Doctor Who, of course. You can't talk about time travel and not talk about Doctor Who.
The
And
doctor. You
the
can't.
Doctor,
The doctor. You got to call it by like what he goes by. Or he, she. The
the
doctor.
Doctor. Yeah. The Doctor travels freely through time and space, often creating or avoiding alternate timelines, showing many worlds, ideas, and in action.
Yeah, and if you've watched that show for any length of time, I mean, I've watched it from since I was a kid. The Doctor goes through many worlds,
Right,
many,
right.
many, many, many worlds. But let's talk about Interstellar. So Interstellar shows time dilation near a black hole. Hours on a planet equal years on Earth. So this is really based closely on real physics.
And Avengers Endgame. Heroes travel to the past versions of their own timeline, showing a timeline splitting and paradoxes creatively.
So it's got a mix of real science and speculations. Some movies stick closely to physics, like Interstellar, while others kind of play fast and loose for storytelling, like Back to the Future.
And filmmakers often consult physicists to make time travel plausible, even when bending the rules.
Yeah, so time travel stories make abstract physics concepts understandable and exciting. I would agree with that to an
Yes.
extent
Yeah. Yeah. Could be a
because
little daunting.
like particle accelerators,
I
flux
mean,
capacitors,
I don't know. You get to the end of the movie and it's just a constant loop, and it's just a wow. There was no resolution. There was no closure. It was
looping,
just looping. Yeah.
like the looper.
So paradoxes, relativity, and quantum ideas become fun and engaging through storytelling, and it helps audiences imagine the possibilities of science without needing a lab or a spaceship.
But here's the thing. Let's get to some practical limitations here. Forward time travel is possible, but very limited. You would have to use high speeds, almost close to the speed of light, or strong gravity. And we can travel into the future slightly. So think about what I just said. If we're using strong gravity, we're in space. There's no way we don't have the technology to travel at high speeds close to light yet.
So the astronauts on the International Space Station aged just a tiny bit slower than people on Earth.
Yeah, so this is real. It's measurable time travel, but only by fractions of a second or milliseconds with our current technology. But if that changed anytime in the future where we could go faster, we might could change that to seconds instead of milliseconds.
But backward time travel is essentially impossible today. Building a time machine would require enormous energy and materials we just don't have, like stabilizing a wormhole with exotic matter. Or even if theoretically allowed by physics, it is far beyond current engineering capabilities.
We'll kind of talk about some experimental physics that are exploring time. You got the particle accelerators. If you know Barry Allen, that's how he got his powers. Um, but don't go messing with particle accelerators, okay? This really kind of studies how particles move near the speed of light, showing time dilation in action. We should do one on particle accelerators.
Yes.
Okay.
We've added a whole lot to the shopping list here in just this episode. So atomic clocks, they measure tiny differences in time on planes, satellites, or at different altitudes.
And then you have quantum experiments, like superposition, branching universes, and other phenomena that hint at strange time behavior.
Right. And these experiments confirm Einstein's predictions and push our understanding of time even without a time machine.
So, what we're saying here is humanity may never travel backward in time, but the universe continues to reveal its secrets, right?
Right.
And we're
And
all time travelers. We're continuously going forward in time.
right. And studying time travel teaches us about reality, physics, and our place in the cosmos.
Even though we imagine time travel, it kind of expands science, uh, philosophy, and storytelling. It really kind of lets our minds explore the impossible, like Doctor Who. He's always doing something that's impossible.
All the time.
The Doctor. I'm sorry. The Doctor.
The
Did I say
doc
it right?
It's close enough.
I'm not British, you know. The Doctor? Is the Doctor in the house? What is your
Doctor,
name? The Doctor?
doctor,
There you go.
doctor,
The Doctor.
doctor.
I want me a little blue box.
Yes, yes. Casey had one on his keychain for the longest time.
Yeah, I want me a little blue box. I want a real one though. Like I can just step inside and be like, oh, I'm traveling in time, man. I don't know.
It's bigger on the inside.
What is it called? You know, where you share a book, you can leave a book, pick up a book.
Yeah.
There is one that they built the TARDIS out of in Macon, Georgia.
Oh, I
It's
love that.
downtown, and you can walk inside and share a book, give a book, and you walk inside the TARDIS there. It's pretty cool.
Nice. Heck yeah.
Yeah, I found a geocache at one time. Anyway, let's wrap this thing up.
So we've talked about relativity and time dilation, quantum interpretations, wormholes, and paradoxes.
Yeah, you know, we've talked about how time travel is as much about imagination and understanding the universe as about time machines.
You know, even if we can't physically travel through time, the more we understand it, the more it shapes our lives today.
I say let's have a little fun here. What do you think?
Absolutely. Okay. So Albert Einstein, the distinction between past, present, and future is only a stubbornly persistent illusion.
Kemp Thorne, he had a famous quote here. Wormholes are allowed by Einstein's theory, but whether they exist in reality is still unknown.
Stephen Hawking, time travel may be possible, but it's not practical. He even held a party for time travelers. No one showed up.
Marty didn't show up.
Mm-mm.
The doc, the doctor, oh, my bad. So we got some, let's do a quick mind bender thought experiment. What do you think?
Yes.
Okay. So the stopwatch. What if you could stop time for everyone but yourself? You wouldn't actually move faster because time itself has stopped. Light can't reach your eyes, and you'd be stuck in darkness.
Hmm. The reverse aging idea. If you could travel backward in time, would your body age in reverse or would you stay the same?
What about the memory paradox? If you change the past, would your memory update or would you remember both versions of history like Marty did? I'm just saying.
Right. Right. The message paradox. You receive a note from your future self warning you not to open a door and you obey. But then, how did your future self know to send you the note if you never opened it?
But now let's get back to the Flash to kind of help us explain all of this because, well, I'm that person.
Well, if you must.
So the Flash can travel through time by running faster than a light, allowing him to visit the past or the future. And in Flashpoint, Barry goes back to save his mother from being murdered, and he really alters history in major ways. Thomas Wayne becomes Batman instead of Bruce. Wonder Woman and Aquaman are at war, causing global destruction. The Justice League never forms because key events in history were, well, they were changed.
So, this illustrates the butterfly effect. Even one small change in the past can cause large, unintended consequences in the present and future.
You know, the Flash makes everything make sense, right?
Yes.
All right, Kat, that's pretty much all I've got. You know, I got to throw in the Flash, Batman, Wonder Woman, Aquaman, and even Avengers Endgame.
Yes. Yes. Yes, we did. We threw all the peoples in there.
And not to mention the Doctor and Marty McFly, the best time
Hmm.
travelers of all.
Of all.
Of all.
Anyway, if you would like to support this podcast, tell a friend and help get the word out.
If you would like to help us keep the show going, you can do so at Patreon. The link is in the show notes.
William and I want to thank you for listening, whether you're
Yes.
new here or have been here for a while.
Yes, absolutely. Sorry, I didn't mean to cut you off on that one.
All good.
Uh,
Yeah. Join the Facebook group and info on the go
Over there, you can share with us your show ideas.
or ask us a question.
Do not forget to hit that subscribe and follow us wherever you get your podcast.
Send us a text using the link in the show notes or leave a review.
It really does help others find us. You can also email us at,
infoonthegopodcast@gmail.com.
and you can find that link in the show notes. Till next time.
Stay curious.